Have you ever tried weighing the Earth? How about the Sun? As it turns out, there's no need to put them on a scale. All you need to know is one fundamental constant that defines the shape of our universe, the gravitational constant. In the late 18th century, British scientist Henry Cavendish wondered about the force of attraction between two lead spheres. He suspended these spheres on a wire and was able to measure with incredible accuracy the force with which they pulled each other and stretched the wire. Knowing this force and their mass, one can calculate the ratio between mass and the acceleration with which it attracts other objects. After Cavendish calculated the gravitational constant, he also calculated the mass of all cosmic bodies, whose acceleration and distance we know. Now we not only know the exact mass of the Earth and the Sun, but even the mass of the black hole in the center of our galaxy. And all of this is thanks to measuring the tension of the wire between two spheres. Did you know that the Moon does not revolve around the Earth? In fact, celestial bodies rotate around a common center of mass, not each other. However, if the mass difference between the bodies is very large, it appears as though one body is revolving around the other. For example, the Moon is approximately 6 times lighter than our planet, which is why it seems to revolve around the Earth. But in reality, both the Moon and the Earth are rotating around a point located about 4,500 kilometers away from the center of the Earth. This is more than 70% of the Earth's radius, so the movement of our planet appears not as rotation, but as a swaying back and forth. Due to tidal phenomena, the Moon is gradually moving away from our planet, and in a billion years, their common center of mass will move beyond the Earth's surface. After that, they will rotate around an empty point in space between them. Did you know that the Sun can enlarge a pixel on your phone to the size of the Earth? As light passes near a massive object, it is deflected towards its center. The same happens in ordinary lenses. The Sun is the most massive object in our system, and it works as a gravitational lens. Every lens has a point where it collects light. There we can observe objects at an enlarged scale. Such a point exists for the solar lens, but because the Sun is not very massive by cosmic standards, its focus is at a distance of 83 billion kilometers, which is equivalent to the distance that light travels in 77 hours. Theoretically, a light collector could be installed there, and then we would have the most powerful telescope ever created. It would enlarge objects by 100 billion times. The diameter of a pixel on an ordinary phone is 0.13 millimeters. Such a telescope would enlarge it to 13,000 kilometers, which is slightly larger than the diameter of the Earth. Have you ever wondered why the Moon always faces the same side towards Earth? The rotation of the Moon is 100% synchronized with its orbit around Earth, which is why we only ever see one side of it. But could such a coincidence be possible? Of course not. The answer lies in tidal forces, not on Earth, but on the Moon. At the beginning of its existence, the Moon made one rotation every 5 hours. However, the gravity of the Earth affects the shape of the Moon, creating a bulge on the side facing Earth. As the Moon rotated, this bulge moved across its surface and, due to friction, converted the energy of rotation into heat and the Moon's orbital speed. As a result, the Moon moved away from the Earth and heated up a little. This continued until all the rotational energy was transformed into heat and motion. The Moon is not the only satellite in the solar system that has undergone tidal locking. Many other objects, such as Jupiter's moons Io, Europa, and Ganymede, have experienced it as well. Did you know that all earthly organisms are written in one language? Whether a living cell becomes a whale or a fungal mycelium is determined by two types of molecules that are universal to all life: the double-stranded DNA and the single-stranded RNA. These molecules are like books, and the most interesting thing is that they are all written in one language, which we call the genetic code. It consists of only 5 letters, nucleotides, that form words representing 20 amino acids. Just as all books written by humans differ only in the order of letters, all living organisms initially differ only in the order of nucleotides in their instructions. Ribosomes read these instructions and assemble the proteins prescribed by them, which, like microscopic builders, create a living organism. The same sequences of nucleotides mean the same amino acids for all life on Earth. This is equivalent to if all people spoke and wrote in the same language. Can neutrinos travel faster than light? In 1987, a burst of neutrinos was detected on Earth, and 3 hours later, observatories around the world witnessed a supernova explosion in the Large Magellanic Cloud. This means that the neutrinos created by the explosion arrived at Earth 3 hours before the light. But can anything move faster than light? Of course not. The explosion of a star happens from the inside, not on the surface. While light generated by a thermonuclear reaction must overcome the thickness of stellar matter to escape, this is not an obstacle for neutrinos. They pass through matter almost as easily as they pass through a vacuum, hardly noticing it. So when a star starts to explode, neutrinos created by the explosion instantly shoot off in all directions, while light, like a solar bunny in a mirrored room, is forced to jump from atom to atom until the shock wave tears the star apart. This is why neutrinos told us about the supernova explosion 3 hours before we could see it. Why does it seem to us that we are at the center of the universe? If we look through the most powerful telescope, we find that the universe extends outwards from us in every direction at an even distance, as if we are at its center. Does this mean that Aristotle was right and that Earth is actually the center of the universe? Of course not. It's all due to the speed of light. No matter where we are in the universe, we will always perceive that we are at its center because light from other parts of the universe takes time to reach the observer. The universe is 13.8 billion years old, so we only see the part of it that light has had time to reach us from during that period. And since the speed of light is constant, we see the same 13.8 billion light-year radius in all directions. We are at the center of the expanding visible sphere, but it's not the boundaries of the universe that are expanding, but the boundaries of what we can see. It's like a person sailing on the ocean believing they're at the center of the world because the horizon is equidistant in every direction.